Hello, and welcome to Ask Dr. Dawn. The opinions expressed in this program are those of the speakers, and this is a program intended for education and entertainment. It should not be construed as a substitute for a medical consultation. Well, I thought I'd start out with new hope for arthritis sufferers. I've got two really exciting news stories. I want to tell you a little bit about this research also in the context of why science matters, and that is a political issue at the moment. I don't think it should be, but it is and has been for quite some time in the game that they play up there in Washington. Anyway, this is a happy ending to some research funding that's been invested by the federal government into a biomedical research agency called Advanced Research Projects Agency for Health. We're going to talk about the agency a little bit. They had $2.5 billion to spend in 2024 in their budget, and they used that to fund grants. And among the products of those grants are two different research projects that are very promising. I want to point out that these grants require that whatever you're working on, you have to bring it to human trials in 18 months after you get the grant. So this is a fast track kind of moonshot sort of approach. And that works because it causes people to select projects that are likely to work in that time frame. Duke University researchers created injections that allow cartilage cells to divide and remodel bone. We'll be talking about that in a little bit more detail, but I want to talk about the University of Colorado Boulder. University of Colorado Boulder identified a repurposed drug that regenerated the knees of rabbits with a single injection. This injection was a drug delivery approach. They patented this. The primary investigator, if you want to look deeper into this, is Stephanie Bryant. And it's a particle delivery system injected into the joint that provides intermittent bursts of a regenerative drug. So it's a delivery nanobot, effectively, a delivery system that gives a burst of the drug and then shuts it down and then a burst later on. And that's the best way to signal healing in body tissue is if you have just a monotonous sound, you stop hearing it, your ear adapts. Well, the body adapts as well. So by turning the drug on and off, you actually are sending a signal for regeneration. And they haven't named the drug publicly because it is already an FDA-approved medication being repurposed. So they gave the rabbits the equivalent of an ACL tear, and the rabbits quickly developed osteoarthritis. And they then injected this material into these rats who had essentially an ACL tear and arthritic joints as a result of the grinding of the loosened tissues. And the joints returned to a healthy state within 4 to 8 weeks. So they were able to essentially reverse arthritis by triggering the body's own healing mechanisms. They also worked on a special cocktail of engineered proteins, that is to say, things that have been CRISPRed or otherwise adapted to create proteins that are new to nature molecules. And these can be injected arthroscopically and cured, presumably using UV light through the arthroscope, into place. There it recruits the body's own stem cells to patch the gap. And this is, one of the problems going at least 10 years back is that we can inject stem cells into a knee, but they just grow in lumps. What this is doing is creating a substance that essentially attracts the stem cells so that they go to the location where the bone is damaged and literally grow in a healing patch. So they looked at both of these procedures and found that they were getting really good healing. And they had human cells derived from patients undergoing joint replacements, and they just wanted to see what would happen. Those cells also became stimulated to regenerate. So we're looking at something very cool there. The other study at the Columbia University, they created a living 3D printed human knee, and this was built just like the titanium artificial knees that are currently used. So they essentially printed this thing in a biodegradable scaffolding. And then inside that scaffolding were human stem cells, either from the patient's own body, and they also used adult donated inducible pluripotent stem cells. So these cells regenerate the joint's natural cartilage and bone. They rebuild. Oh, this should be bone. I'll turn into a bone-building cell. Oh, this should be cartilage. I'll turn into a cartilage cell. So having the 3D printed matrix, blueprint, on which to grow, the cells knew what to do. There's a lot of innate programming in these stem cells. It's amazing what can be done. So this could be implanted in place of a metal and plastic replacement joint. Those wear out in about 10 years. So this work on knees cost about $42 million for the Columbia design. That seems like a really good deal compared to what we spend on joint replacement in this country every year. And this entity, which was doing the funding, the Advanced Research Projects Agency for Health, had their budget, which was $2.5 billion, cut by $945 million by our fearless leader. And so we can expect that the pipeline for these kind of breakthroughs has been drastically slowed. And I personally did not vote for that outcome, and I think most of the people who voted either way in the last election did not think that the cancer moonshot work, also very important, and we have a study about that as well in the program. We didn't think that the cancer moonshot was going to get canceled because that was not good research. That was not valuable research. And particularly with the time to human trials of 18 months, you can't dawdle. You better have something already in the works that is close to production. And if you think about it, this company is working a lot like venture capital from the government. It's picking likely prospects and funding them so that they can, quote unquote, get to market. And I mean, that's a good strategy, and it's certainly a winnowing strategy when you have limited research funding. But I don't think we need to be limiting this particular entity's funding further because it's coming up with some prizes. We'll move to our next story. This is a short one about more chemicals in our environment. These are two types of phthalates, that's spelled Phth. I think it's the only word in the English language with that many consonants stacked on each other. But phthalates are not forever chemicals. They're everywhere chemicals because they turn up in everything from food packaging, vinyl flooring. They used to be in pacifiers. They're in shampoos. They're in children's toys. And they get into the food supply very easily, particularly if you microwave in plastics. Please don't do that. I know it says you can on the plastic bag that the food came in. Just don't. Okay. So phthalates have been known to interfere with hormone production. They've been linked to infertility, low sperm count, obesity, diabetes, and cardiovascular disease. But this latest science report found that these drugs uniquely affect the placenta, and they're linking them to problems with premature birth. They disrupt the placenta and interfere with gestation. So the new study looked at 200 countries in 2018, finding the worst affected areas were the areas where you would expect, and this was a cord blood study. all of the rapidly growing plastic industries with high levels of plastic waste, the places where the plastic gets shipped to that you put in your recycle bin. We have to get ourselves unhooked on plastic. This is not going to work saying, okay, well, phthalates are bad, let's take the phthalates out, because they just get replaced with another chemical. It sort of reminds me of about the designer narcotics and designer drugs that are being produced, because in that situation, you can only declare a particular molecule illegal. So LSD is illegal, but if someone were to design an LSD-like drug that differed just enough from LSD, it would be legal until the authorities caught wind of it and made it illegal, and that's going to take years. And meanwhile, the people who are synthesizing this stuff can essentially operate in that gray zone where it's not approved, but it's also, what's the saying? That which is not forbidden is permitted. I think that's the way it goes. Not necessarily the best strategy when we're talking about environmental pollutants. We're going to move now to an email from a listener. This from Lloyd in Santa Cruz, and Lloyd writes, Microbiome and Loving Exercise, National Geographic article on why and how the microbiome may contribute to some people really loving exercise. We got the article, and I tried to get the scientific article, but that was behind a paywall, and I didn't have time to hack the paywall. So I did. They wouldn't even let me have the abstract, which I thought was very rude of Nature Medicine, but oh well. Anyway, some mice have microbes in their gut that motivate them to exercise more. Scientists are asking whether the same might be true for humans. There are definitely species of mice that are more inclined to run on an exercise wheel than their less active counterparts. And what a recent study shows is that these mice carry microbes in their gut that send signals to their brains, boosting the desire for exercise. Well, we've known for a long time that regular exercise is good for health and decreases the risk of many diseases. But more than 80% of adults don't manage the recommended 150 minutes per week, even though lack of physical activity causes probably as much as 10% of premature deaths. In fact, sedentary lifestyle is estimated to be the fourth leading cause of death worldwide. We just don't count it statistically because we don't put it on the death certificate. Yes, he died of sedentary lifestyle. No, the coroner is going to kick that one back to me and say, no, but what codable disease did he have? Anyway, getting back to the story here, exercise affects the gut microbiome. We've known that for a long time. If you're a regular exerciser, you have different bacteria and dominance in your microbiome. But what was not clear was how the microbiome affects exercise behavior. And in this research, a study found let's first of all talk about humans. In 2019, a study done after the Boston Marathon looked at the microbacterial species of runners versus sedentary volunteers. Presumably, these people were eating similar diets and were in a similar place at a similar time. They found that there was a particular bacterial species that was found, and that species is Veillonella, Veillonella, atypica. And this particular microbiome is part of a phylum that is one of the things that the DNA fingerprints of the gut can give you a sense for whether you have high levels of that, but we don't have the fine-tuning to get down to the species level. But this particular bacteria, of course, when this paper came out, was immediately commercialized, and I did a quick check, and you can find it. Now, how does this work? Well, the main way that this works is because this bacteria likes to eat lactate, which is the analog of the lactic acid that you produce when you exercise hard and you use up all of the ATP, you outrun what the mitochondria can do for you, and you have to switch to anaerobic metabolism. anyone who's over-exercised and had sore muscles afterwards knows what I'm talking about. Well, this lactic acid is going to leave the region of the muscle through the lymphatics, and it's going to dump into the bloodstream, go through the heart, and pump to the lungs, and then oxygenated is going to go to the vasculature throughout the body, and it's going to be thus available, because it's a very small molecule, it'll diffuse into the gut where this Veillonella bacteria can eat it. Now, this bacteria can drive the production of dopamine, which is a reward signal in the human brain. And so when it has plenty of lactate, it makes plenty of dopamine. The dopamine climbs up the vagus nerve into the brain, where it generates a feeling of, a good feeling, a feeling of fulfillment. It's essentially a Pavlovian behavioral medicine loop that is being puppeteered by our microbiome. Now, the good news about this puppeteering, as opposed to, say, let's call it NI, natural intelligence, the NI puppeteering is good. I'm not so sure about the AI puppeteering that we're all subject to just about all the time now. The algorithms and all of that stuff, that's been talked to death, so I won't, you know what I'm talking about. The good news about the NI is that they die when we do. So our incentives are aligned, as one might say in business. And so I'm inclined to believe that the bacteria have its own self-interest, which just happens to coincide with our self-interest and help us stay alive longer for the reasons I've just suggested. So another researcher in the same topic, this is Cruz, a microbiologist at the University of Pennsylvania, wanted to know what prevents most people from wanting to exercise. And so they decided to study mice, because naturally it's very hard to study people. And some of this variability in motion is probably related to genetics. A researcher, Theodore Garland, who is an evolutionary biologist at UC Irvine, was studying that. He was studying complex traits like marathon running. And he came to the conclusion that they evolve at multiple levels of organization, ranging from behavior and, of course, this microbiome, but also DNA. He launched an experiment way back in 1993 to breed a strain of super runner mice. They've been bred now at this point over 100 generations, and looking at the specific changes in their DNA. And they evolved changes that were easy to evolve. So some of them were point mutations, and some of them were making more copies of specific genes. That's called copy number variation. And a lot of inheritable characteristics are done by, you just make more of it because you have more copies of it. And so you can, pull off more transcriptions per unit time than the next person when stimulated. Anyway, these mice that were born to run, so to speak, ran 3 times longer than average, and they had different microbiomes. Now, here's the cool part. They gave the athletic mice antibiotics. What happened was that the super runner, marathoner mice stopped running. They ran about 21% less every day. They were otherwise unaffected, but it irreversibly reduced the voluntary exercise behavior of the mice, implicating, obviously, the microbiome. There's an insane amount of data going on here. We need AI to analyze this level of data. Humans simply cannot keep it all in their heads at the same time. But there are 10,500 data points in the data set to understand this, including the bacterial sequences of all the mice, their gut bacteria, the metabolites. And as they work on understanding this, I am struck by the fact that bacteria is available, and I wonder if it would work for me. So I'm going to buy some and start taking it and see if I'm reasonably adherent to my exercise program, but sometimes I prioritize other things. I'm wondering if I can leverage my microbiome to change my priorities and help me be more adherent to my not terribly strenuous exercise program that still gets me that 150 minutes a week. So we'll see what happens, and I'll report back after I score some of this stuff and have a better sense for how it works. One more story from last week that was just at the very end, and I think I'm going to expand on cortisol. And the question that one of the younger people in the audience had asked was, when is cortisol good and when is cortisol bad? And I first want to talk about the limitations to our ability to study cortisol. And part of the problem with, like, if you go to the doctor and you're really tired and you're really wrung out and you have a sort of chronic fatigue picture, the doctor may check your cortisol level. And what I find is that it's almost always low normal when you go to the lab in the morning and check the cholesterol. And part of that is because cholesterol is very dynamic. It looks more like a seismograph than anything else. It jitters, it's up, it's down, it's up and down, but it does have a global trend line, and that trend line is that it gets low in the middle of your night, and then if you're, let's say, getting up at about 6 to 7, it starts to increase at about between 2 and 3 in the morning. And this is key. It should increase smoothly and not be spiky, but in people with depression, for example, who tend to have dysregulated cortisol, and in people with with problems with other hormones, like, for example, if you have insulin issues, not responding to insulin, in other words, having insulin resistance, you can have that 3 a.m. kind of hot flash thing. And it's attributed largely to hypoglycemia, but I think that's incorrect. I think that cortisol is playing a big role here. And of course, women who are in the menopausal or perimenopausal transition also experience that, as well as the problem with temperature regulation. But the point is, if you have that 3 a.m. awakening, you're probably having a spike of cortisol. But normally, what it should do is increase gradually, and as it starts to increase, the system starts to rev up, because this is the downbeat of the tempo of your day. And there's a big cortisol spike. It's about 3 times the level of cortisol that you're going to have through the rest of the day. It's a good-sized spike. And that just gets the whole system started, gets all the other clocks ticking. The testosterone is triggered, so that gets a bump. All of these things happen because of the cortisol downbeat. And when a person is under chronic stress, this is where things start to go bad. But first, the normal curve. 3 times higher, then it's dropped to about 50% of that by 3 hours out. 3 or 4 hours out, it continues to drop more slowly, but the first drop is pretty precipitous. Then for the rest of the day, the other 50% comes down on a slow spike, kind of bottoming out at bedtime and staying low until it starts to pick up again at 3 a.m. So that's a normal cortisol curve in a healthy person with a healthy circadian rhythm. And what happens when you are stressed all the time is that you put out more cortisol. So you get your spike, but then it doesn't drop. It stays up and maybe never gets back to the typical healthy level. Maybe it drops down. It may spike higher than normal and then drop down such that you're at the 11 a.m. level all day. And that's going to cause a person to be kind of more uptight and nervous. And they may get a kind of crash after eating and get very, very sleepy. the next stage when this starts to go really wild is now you start getting spikes and troughs throughout the day. And then this is where you get the people who are really tired in the afternoon and really tired after dinner, and then maybe 3 hours after their dinner at 6 p.m., they get a burst of energy. They get another spike, and absolutely the wrong time because they should be going to sleep. And that pattern, those people are the people who are coming into my office with insomnia. Another group that will show this pattern is young people who are doing a lot of texting and computer stuff at night or gaming, and they just aren't following a sleep cycle. And this is often a problem with teenagers whose cortisol clocks are shifted because of their other hormones. And so cortisol can be bad when it's too high, and of course it can be bad when it's too low. Now, there are a couple of diseases that are called Cushing diseases. One of them is when the pituitary doesn't release the cortisol, the adrenal cortical stimulation hormone that doesn't cause the cortisol to be released. And another one is when the adrenal gland can't produce any cortisol because it's been attacked by autoimmune. And then there are versions where there's too much stimulating hormone released, and versions where too much cortisol is being released because there's a tumor in the adrenal gland that's making cortisol on its own. That's kind of a bit like Graves' disease in that there's an overstimulation that's just broken control system. So those are the manifestations, and chronic stress and chronic overstimulation, so too much fight or flight, leads to too much cortisol, trying to chase that. And too much cortisol over a long period of time exhausts the gland. And then people really start to crash. And one manifestation of that can be a sort of chronic fatigue picture. And once you're there and your circadian rhythm is really disrupted, it takes 6 months to 12 months of conscientious work to get it back. So you don't want to bottom out your cortisol. And I just have to emphasize moderation, all right? Get enough sleep, not too much, enough. Eat, exercise, whatever else you're doing, have a blend, be moderate in it. That's the key to keeping a healthy adrenal gland. If you're under a lot of stress at work, cut back on your commitments. Make a point of doing things that give you pleasure and that are relaxing. If you're under a lot of stress at work, don't go and do extreme sports on the weekend. Sure, that'll get you some dopamine and some endorphin, and you'll feel relaxed, but you're going to burn out. And I see a lot of people with cortisol burnout who are just super high achievers at work and super high achievers physically as their recreation. And, that's a candle at both ends situation. You should treat your body as well as you treat your dog. Regular meals, walks on a regular basis, and your body will thank you, and so will your brain. We're going to continue with the last question here, which I love. How would someone support detoxification pathways through foods? Main goal is to improve skin and reduce inflammation. Wow, what a fun question for me. Let's start with the detoxification piece. So a lot of foods support detoxification, and they support it through these molecules called bioflavonoids, which are basically plant insecticides. And for the plant, they're to keep it from being eaten from insects. But what the body does with those chemicals is it uses them as a signal to make more enzymes to break down those compounds. Now, it just so happens by an amazing coincidence that the enzymes that break down the bioflavonoids in food actually also break down pollutants. So they break down the, there's so many, all of the polysyllabic compounds, the acrylamides, the PFAs, the polyvinyl chlorides, we can go through thousands of these new to nature molecules. There are 50,000 things in our environment that weren't there, 150 years ago, because they only existed after the golden age of chemistry started making them. And the problem with these is that they're harder to break down because our body doesn't. So pushing the detoxification system is very important. And for that, you need molecules like sulfur. Sulfur is an extremely useful detoxification compound, and it's found in the sulfur-containing vegetables, which is your crucifers, and it's also found in onions, garlics, and leeks. So the compounds that we want to support for our detoxification would include a wide variety of different colored fruits and vegetables, because you also said reduce inflammation, and one of the ways that they do that is they are free radical scavengers. So the reactive oxygen species, and we generate these all the time with our own physiology, and they're like little sparks that can land on your DNA and burn it and cause a mutation, and they can land on your collagen and burn it and cause a wrinkle. They can land on, they are part of aging, just the free radical damage that occurs through time. Like I always say to my friends, the stuff that stuff either gets too loose or too stiff, but it isn't the way you want it to be, and it all goes in the wrong direction, and that's time and free radicals and ultraviolet as far as the skin is concerned. So it's very important to eat a wide variety of plants. Plants are anti-inflammatory. Meats are pro-inflammatory, with the possible exception of high omega-3 containing foods like fish, large ocean or oily fish like small little sardines. Learn to love sardines because it's one of the few sustainable things in the world right now. And those little guys can slip through the nets, so to speak, and that's wonderful. And they're very hard to overfish. So what's our main goal here? Improve skin and reduce inflammation. Well, anything that improves your skin also improves the lining of your blood vessels. And a young person isn't thinking about coronary artery disease and developing hypertension in their 40s. But if their doctor is any good, their doctor's thinking about that and trying to steer them on the path so that those somewhat inevitable deteriorations that come over time happen as late as possible in your life. All right, so let's start out with a human interest story as a hook. In 2021, dermatologist David Ozog was on a holiday with his family when his 18-year-old son had a massive stroke. The teenager was airlifted to Florida and then Chicago, and as his son was lying partially paralyzed in a hospital bed, Ozog got a call from a colleague who had an unconventional suggestion. The colleague was a dermatologist at Harvard Med School in Boston, and he told Ozog about research that the colleague, was conducting with the U.S. Department of Defense. Early results were indicating that red and near-infrared light applied to the head might protect neural tissue after brain injury. He urged Ozog to consider trying it. So Ozog, being a good father, stayed up until 4 a.m. reading scientific papers and decided, this looks like it's in what Dr. Don calls the won't hurt, might help category. So he ordered several panels of red and near-infrared light-emitting diodes, and he started sneaking them into the hospital. Well, his son recovered and is back to walking. We can't prove that the light therapy worked, but this idea used to be very fringe, and now it's changing. It was on the margins of medicine, but now we're seeing these red light devices in dermatology offices, locker rooms. People are buying them online. My acupuncturist introduced me to this therapy, and I looked at it, and my jaw kind of dropped, because clinical trials have reported improvements in so many things. Lots of neurological disorders, retinal degeneration, peripheral neuropathy. And expert groups are now recommending red light therapy for certain indications. What's going on here? Well, we think that it's the mitochondria that are being affected by the red light therapy. Humans are exposed to less red light than ever before. We spend more time indoors, away from the sun, and efforts to conserve energy have narrowed the spectrum of indoor lighting, eliminating many red and near-infrared wavelengths. So some scientists are asking, maybe these have biological consequences. Maybe we're being starved of something. And, this is not new stuff. It's just new science, but it's not new knowledge. In the 1903 Nobel Prize in Physics recognized concentrated light as a treatment for skin tuberculosis. And bright light therapy is standard for seasonal affective disorder. And, of course, we use narrowband UV light for psoriasis. And this is now called photomodulation therapy. And we're talking about red and near-infrared light running from about 600 nanometers to 1100 nanometers. And these influence cellular processes in plants. It's been shown since the 1960s to accelerate hair growth in animals. Last year, the Food and Drug Administration approved a red light device for age-related dry macular degeneration. And red light therapy in the mouth is included now for preventing and treating cancer therapy-related oral mucositis, which are the painful ulcers that arise. It is an inexpensive therapy that right now is only used in about 10% of cancer treatment centers, but it needs to be expanded because it works. It improves healing, reduces inflammation, all the good things, because it helps with mitochondrial recovery. And if your battery is low, you can't do anything. You can't heal. Healing is expensive and costly in energy. We've seen decreases in pain for people with osteoarthritis and fibromyalgia. And maybe some studies, very preliminary, show benefits in metabolic disease. Also, in 2022, there was a small study in Brazil that found that just putting people with severe COVID out in daylight, and of course they got plenty of that in Brazil, cut their hospitalizations by an average of 4 days compared to controls. Mouse models of Parkinson's disease, it gets through the skull, which just blows my mind. And it doesn't surprise me in mice, but the fact that it gets through the skull in humans, our thick skulls, kind of is crazy. But photomodulation preserved dopamine-producing neurons that located deep in the brain, like in the mouse brain that's 3/4 of an inch down. And that light is getting down there and having an effect on the mitochondria. Red and near-infrared wavelengths of light scatter much less than blue and ultraviolet. So some of those photons, most of them in the near-infrared range, can pass through clothing, and a fraction of them can penetrate centimeters into the body tissue. So they can affect cells well below the surface of the skin. So that 600 and 700 nanometers, and also the 760 and 900 have been tested, and they all produce biological responses. And those are the wavelengths, and this is where light comes in. Those are the wavelengths that are readily absorbed by a molecule in the mitochondria called cytochrome C oxidase. And this is a key enzyme in the electrotransport process that generates ATP. So the light seems to nudge the electron transport process into a more active state, boosting the production of ATP. So for results downstream, you get improved blood flow, changes in inflammation, reduced oxidative stress. And this was another mechanism that blew my mind. Red and near-infrared light actually reduces the viscosity of water, allowing the energy-producing machinery within the cell. It's actually acting as a lubricant. Getting light makes a huge difference. Retinal health is another one, I think. They were looking at this other group was looking at photomodulation in macular degeneration. And he actually found that you didn't even need to put the light directly into the eyes. It could just be being out in the sun actually helped the eyes heal. In an earlier research, they found that 15 minutes of red light exposure on the back of a person blunted post-meal spikes in blood sugar levels. So the mitochondria seem to be behaving as a community all across the body, and there's some really wild mitochondrial quantum effects that I don't understand. But, things that we think of in quantum, like electron tunneling and such, are actually happening inside our own body cells. And mitochondria and other cells in our body actually produce light. They're called biophotons, and they're very faint, but they're little photons. And they found that photomodulation altered the production in stressed cells. And this is important. This is something that's coming out of a lot of different research, that if cells are healthy, external light doesn't do much. But during illness or metabolic stress, in which mitochondrial dysfunction is common, that's when it has an impact. And of course, what do we do with our illness behavior? We stay inside and kind of watch TV. In other words, we deprive our body of that infrared light that we evolved to need. We evolved under sunlight. And that's a spectrum of sunlight that's like 300 to 2,500 nanometers. For most of human history, indoor light had similar characteristics. It was just dimmer daylight. But as we start to see the biological effects, just as we're starting to see it, possibly because of the deprivation, we're now being able to really understand our buildings are largely stripped of these wavelengths, and that's where people spend about 90% of their time. And modern window coatings filter many of the longer wavelengths of sunlight in order to reduce the cost of cooling off the buildings. And our light bulbs, fluorescents and LEDs, are a narrow portion of the spectrum. They don't give us these frequencies. Oddly enough, those old incandescent bulbs actually did a very good job of giving us these frequencies. In fact, 90% of an incandescent bulb's energy is in the infrared area. That's why you can burn your hands on them. I kind of did that enough in my life that I still have to think twice before I'll touch a light bulb. 150 years ago, Florence Nightingale, who was one of the founders of modern nursing, insisted that full-spectrum light was essential for recovery. She wrote in 1859, "Most people think the effect is upon the spirits only. This is by no means the case." Smart woman, paid attention. People can now buy all kinds of devices, mats, helmets, panels, sort of tanning bed-like thing. These may do something, but don't expect miracles from these commercial devices. They are just like that probiotic that's out there that's going to improve your ability of exercise. Proceed with caution. NASA's looking at it, near-infrared light therapy to support mitochondrial function during spaceflight. Now, spaceflight is definitely a stressor, so that makes sense. But what we can do is just redesign our world so that we get more outside light, and maybe get a panel and use it yourself. Maybe you will notice an improvement or a reduction in your risk of macular degeneration. You won't notice that one. You just won't get it. Other researchers in this are playing around with red light for themselves. And of course, there's a lot of confirmation bias going on with something like that. But it's still impressive. And I had, after my experience with the acupuncturist, jumped on the red light wagon for a beauty treatment. I'll be frank, I'm 67 years old and I'm trying to reduce all of the signs of aging in my face, and I honestly say I think it's working. And so, again, it's not scientific, it's anecdotal, but there's science behind it. And I'm particularly interested in what I'm hearing about the neurological benefits, because we have very, very little to offer in terms of neurological regeneration or and treatment for example, peripheral neuropathy is basically a Band-Aid. But what if we could what if we could help those nerves heal their mitochondria so that they're no longer screaming like a hungry baby? Wouldn't that be amazing? Well, we've got just about 5 minutes left in the program, so I think I'll read this bit, or at least part of this bit. This is an article by Lachlan Brown, and someone sent it to me, and I thought I would share it with you. My daughter is 3 years old, and already her childhood looks nothing like mine. She has a schedule, a routine, structured play, supervised activities, and two parents who are almost always within arm's reach. By every modern standard, she is getting exactly the kind of attentive upbringing that experts recommend. But sometimes I watch her and I think about my own childhood in Australia. The contrast is so sharp it almost feels like a different species of growing up. Because nobody supervised me, no one structured my play. My parents weren't reading parenting books or optimizing the development. They were at work or in the kitchen or simply elsewhere. According to a growing body of research, that absence of parental supervision may have been one of the most important things they ever gave me. If you grew up in the 60s or 70s, your childhood probably looked something like this. You left the house in the morning, you came back when the streetlights came on, and in between you figured things out for yourself. You settled your own disputes, you managed your own boredom, you fell out of trees and learned, without anyone explaining it to you, that gravity was not negotiable. Your parents weren't negligent in the way we define it today. They just operated on a completely different set of assumptions. Children were durable. The neighborhood was safe enough. And hovering over your kids wasn't considered good parenting. It was considered odd. In a Harvard Graduate School of Education interview, psychologist Peter Gray, a research professor at Boston College who has spent decades studying play, described this shift in vivid terms. He explained that from the 1960s onward, there has been a continuous and measurable decline in children's opportunities to play freely, away from adult intervention and control. And over that same period, anxiety, depression, and suicide among young people have steadily climbed. Correlation is striking, but Gray argues it's more than a correlation. The mechanism, he says, is straightforward. Independent play is how children develop what psychologists call an internal locus of control, which is the belief that you can influence what happens to you. And without that belief, you're all set up for anxiety and depression. In 2023, Gray and his colleagues published a major review in the Journal of Pediatrics. The paper makes it hard to argue with systematic removal of unsupervised, self-directed activity from childhood contributing to the mental health crisis among young people. The findings are worth sitting with. Children who engage in independent play learn to regulate their own emotions because there's no adult stepping in to do it for them. They learn to negotiate social hierarchies because they have to. They learn to tolerate frustration, boredom, and minor failures because those experiences are baked into the structure, the texture of unstructured time. Although well-intentioned, adults' drive to guide and protect children has deprived them of some of the independence they need for mental health. That last point is what hit me hardest. The children of the 60s and 70s weren't building resilience because their parents had some brilliant developmental philosophy. They were building resilience because their parents were busy. Here's something that doesn't get talked about enough. The ability to tolerate being bored is a skill, and like most skills, it develops through practice. Children in the 60s and 70s were bored constantly, not the kind of boredom you fix by scrolling a phone, but the deep, restless, nothing-to-do boredom that forces your brain to generate its own entertainment. You stare at ceilings. You invent games with sticks. You spend whole afternoons doing absolutely nothing or staring at an anthill. And somewhere in that nothing, you learned that you could survive unstimulated. That's called self-soothing. not the kind that comes from a breathing exercise you learned in a workshop, the kind that develops organically when a child is left alone with their own mind often enough to be comfortable with it. There's more to the article, but I'll stop there and wish you a wonderful week. I will be back next week with more of Ask Dr. Dawn. Well, that's about all for this week's podcast. Please go to AskDrDawn.com for news about our future plans. For now, this is Dr. Dawn saying so long and stay healthy.
Ask Dr. Dawn is brought to you by Jiva Media. Production and editing by Charles Bansky. Music by John Scoville.